So now we're going to learn how to convert from one unit to another. In physics, we use the metric system, which means what? For distance, we have to make sure we use the meter. Oh, I was about to write M, but I'll use the unit for meter, which is M. Speed or velocity, we'll talk about the difference between them soon. But for speed, it has to be meter per second. So when you get in your car, you start driving at 40 miles per hour, that's not good for us. We have to tell you how many meters per second that is. Acceleration. It has to be meter per second squared. So that's meter per second squared. We'll talk about what acceleration is. It's really the rate of change of your velocity, how fast your velocity is changing per second. Mass. When you weigh yourself on the scale, you go 160 pounds. We don't use pounds here. We use kilogram. Which is kg, kilogram. Not just K. Why not? K always saved for what? 1,000. When you say, I ran a 1K race, you know, that's 1,000 meter. 1 kilogram, that's 1,000 gram. 1 kiloliter, 1 kilo of this. K is always saved for 1,000, the letter K. We'll talk about these units too. Kilo, micro, milli, nano, giga, tera. If you have a hard drive or RAM, we go how many megabytes? You know, mega is a million. Tera is a billion. So capital T, K, M, these are reserved for something else. We'll use them too here. So we have to convert from one unit to another. We need to know how. So we're going to practice right now and show you how we're going to do that. We'll start with the stuff that you and I know. I know that 1 yard is equal to 3 feet, right? But if I give you 1 yard and I says, can you convert that to feet? Well, we know that's 3, but I just want to show you how we do it. Because if you learn this method, you can use it for anything after that. What I tend to do first, I make them a fraction. That's 1 yard, everything over 1. And I want to convert that to feet. I'm going to multiply it by, it's always a multiplication, never a division here. I want to go from yard to feet. Notice yard on the top. That means I have to put yard on the bottom and feet on the top. Why do I want yard on the bottom, not on the top? So they can cancel out, exactly. Notice math here in algebra, if you have the same thing on the top and the bottom, you can cancel that. So you end up with feet. And 1 yard has how many feet in it? 3. So it becomes 1 times 3, which is what? 3 over 1 times 1, which is 1. And the only unit that's left there is feet. So we write feet. So that's 3 feet. Let me try another one. I'll give you a chance to try a few more yourself. You go to the doctor, you're not feeling good. All the medication that the doctor has are per kilogram. They said give them 1 tablet, for example, for 25 kilogram. So they have to know what your mass in kilogram, not in pound. So they might say, how much do you weigh? You go, well, I weigh 160 pounds. Well, they need to convert that to kilogram. What does that equal in kilogram? Again, the same process. 160 pounds over 1. Times, that's my multiplication, the asterisk. I want pounds on the bottom, kilograms on the top. Let's go to that unit conversion, that sheet I gave you. Let's look at kilogram and pound. If I didn't cut the left side, you'll be able to read that quickly because it will go by it, but we have to look and see where is pound and kilogram. Pressure, energy, power, nope, must be on the left side here. There's the mass, we go right in the top. 1 gram, 1 slug. Uh-oh. I don't see it there, unless I'm blind. But one kilogram is 2.2 pounds. Somewhere there, I just don't see it. I need a nicer sheet than this. If you need something that's not there, just go on Google it, and you'll find that answer. But 1 pound equals, 1 kilogram equals 2.2 pounds. So if I use that, 1 kilogram equals 2.2 pounds. So that would be what? 160 divided by 2.2. Notice what I got for an answer. 77.7, or 72, I'm sorry, that's a 2. I'm the worst person with calculators, by the way. I will recommend that you test all the numbers, you try them yourself, because I will make a mistake with them. But it repeats. Now, here's the problem is going to be on that mastering physics. How many significant digits this number has? The 160. 2. The 0 doesn't count unless there's a decimal point here. There's 2 significant digits. How many significant digits this one? 2. They want the answer in 2 significant digits. So this becomes what? Try again. 73 kilogram. Why? Because if it's 5 or more, you have to add 1 to this. So your mass becomes a 73 kilogram. So if you put 72.7, they probably will say correct, but your significant digit is wrong. It should have been 73. I'll give you a little statement there, you know. Let's try another one. I was watching a show on TV yesterday. They were talking about cheetahs and lions and all that. They go at top speed. They can hit about 160 miles per hour. Now, or downhill skiers. If you ever watch downhill skier at the Olympics, they can go about 65 miles per hour. They go, poor Charlie, he lost by 1 second. Well, what is 1 second? How far? If you lose by 1 second in the Olympic, you lost by a big gap there. Because if you go in 65 miles per hour, and I want to convert that to how many meters per second? So it's 65 miles per hour over 1. You're going to multiply that by, I want miles per hour on the bottom, and I want meters per second on the top. Again, where's my cheat sheet? I saw that. I know I have that. 1 mile per hour. Can you see it down the bottom right here? Way in the bottom. It is 0.447 meters per second. So 0.447 meters per second. You are going what? Is that 29.055? Meters per second. So if you lost the race by 1 second, remember, a meter is about 4 inches bigger than a yard. You lost roughly by 35 yards, 32 yards. Almost twice the length of this room. It wasn't that close when you lose by 1 second. When you lose by 0.1 of a second, now that's really tough to lose because that's like the length of that table. You know, a little bit longer than that table. You lost by 3 meters if you lose by 0.1 second. But you'll see all our speed has to be in meters per second. Let's say we have a spaceship that's circling the Earth. This is the Earth. Now we're going to do some math here. Oh, it's all right. This is Earth. And we have a spaceship that's circling the Earth. We're making pretend the Earth is a sphere there. It doesn't really matter for the example. I'm doing it. It can go around the Earth here 6 times per day. I'm just making that up. It goes around that 6 times per day. So the question is how long it takes to go around the Earth in just one circle, one time. What is the time required to travel around the Earth one time? Once. And again, I'm looking for time. That means my time has to be in what? Seconds. So it does 6 times 6 revolution per day. That means how long it takes a spaceship to go around the Earth if it does 6 of them per day? How many?
24 hours.
That's for 6 of them, right? So to do it once, how long? 4 hours. So the time is actually 1 revolution is actually 4 hours. It takes 4 hours to go around the Earth once. Well, we don't want it in hours. I want to convert that to what? To seconds. So the question now, can you convert 4 hours to seconds? Now 4 hours. Let's make it a fraction over 1. And I'm going to convert hours to seconds. Let's look at that cheat sheet again. Time. 1 hour, can you see it right there, like a third from the bottom or quarter from the bottom? 1 hour has how many? 3,600 seconds. So let's put that in. 1 hour, 3,600 seconds. Hours cancels. Four times 3600. 14400. 144, is that 144 or 141? 14400. Now let's assume they ask you to write the answer using two significant digits. If they said two significant digits, what would you write?
140.
Close. 1400, right? 14,000, you mean? Because that's the second two significant digit right here. Is that number 5 or more? No, you make them zeros. 14,000 seconds. Now, what you might see sometimes at the end of that question, they have a little box, the units, instead of seconds, they have kilosecond. Kilo is 1,000. If you see that, then what would you write? 14. Because a kilo is 1,000. That's 14,000 seconds. Every once in a while I do a problem, I test it, I got it wrong. Someone will ask me a question. I look at the units, and they want it in kiloseconds, in kilogram, and mega, tera, whatever the case is. So we have to know K. When you see a K there, K means 1,000. Let's talk about these units: kilo, mega, tera, and so forth. We'll begin with, I don't know. I'll use capital letters. Okay. K. K means kilo, which is 1,000 or 10 to the 3. Mega, M, capital M, which is mega. Megabyte. Your computer has 3 megabytes. It's 8 megabyte. Mega is a million, which is 10 to the 6. T is tera, terabyte, like your hard drive. That's a billion, 10 to the 9. P, I don't have to go beyond that. It's peta, P-E-T-A, which is 10 to the 12. Google, G. Anyone knows what Google is? Not a search engine. That's 10 to the power of 100. That's what a Google is. We'll never use it, but so they came with the name Google from that, 10 to the power of 100. Now, if you want to deal with smaller values, we use lowercase. Notice all of these are uppercase. Now let's look at the lowercase. We'll begin with centi. Well, let's deal with milli for now. We'll use small m. 10 to the minus 3. Centi, like centimeters. We'll talk about them in the metric system, but usually we said millimeters. Micro. Pico. So milli is m, 10 to the minus 3. Then micro. We use that little mu. That's micro. 10 to the minus 6. Nano. We'll use small n. 10 to the minus 9. Pico or pico, P, 10 to the minus 12. And there's other ones, but those are the common ones that we use. Where people get confused with this, where they have problem, they might say, I have 2.4 mega, and I want you to convert that to milli. Milli. Small m. Now this becomes a little bit challenging here, because it said, oh, let's use your method, 2.4 milli or mega over 1. Let me multiply it by, wait a minute, I don't have anything that ties mega to milli. There's nothing. So in a case like this, I can't use my method I just showed you. There's nothing that says 1 mega equals that. We can make one. The capital one's way bigger than these. These are smaller ones. So a mega is what? 10 to the 6? And a milli is what? 10 to the minus 3? So really, if you want to make your own unit, you can say 1 mega is equal what? Anyone? How about 10 to the 9 milli? Why? Because this is one way to picture that. If we look at like a piece of paper, we go, this is the 0, for example. This is 10 to the 1. This is 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6. 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. Where's the milli? The milli is right here. I should put them on the wrong side, left side, right side. Silly the way I put them there. I should reverse them. We always like the smaller one to be on the left, right? The bigger one on the right. I wasn't thinking along that line, but I can change it. Nothing wrong with that, just but we used to seeing 10 to the 0 here, the positive ones on the right. This is 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. This is the milli, and this is the mega. The wonderful thing about metric system, everything is a multiple of 10. Everything is 10. Move the decimal point that many places. Now to go from here, this is bigger than this. By how many times? Let's count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you're here, you have to jump 1, 2, 3, 4, 5, 6, 7, 8, 9 to get to the milli. That's why 1 mega is equal 10 to the power of 9 milli. So if I know that, now I can come back to this one. I got it now. I can use that method. There's the mega, and there's the milli. 1 mega is what? 10 to the power of 9. Now let's multiply. 2.4 times 10 to the 9, that's 2.4 times 10 to the power of 9 milli. think about them like, for example, this is really 10 to the 0 is the ground. And these are above the ground, and these are below the ground. This is 3 levels below the ground. This is 6 levels above the ground. To go from here to there, you have to climb how many levels to get to it? You got to climb 3 levels to get to the ground, then 6 more to get to that level. You have to climb how many sets? 9 of them. That's one way to visualize that. Like if you want to go from tera to nano, or tera to pico. .2 tera. I'm saying, what is that in pico or pico? Tera is 9 levels above the ground. 9. See, 10 to the plus 9. And pico is what? 12 levels below the ground. So 12 level below the ground, then you got to go 9 more above the ground. How many levels are you climbing up there? 21. Tera is much bigger than pico. That's why the power is positive. So this will be 6.2 tera over 1. 1 tera is 10 to the 21 pico. So now you multiply. What do you have? 6.2 times 10 to the 21.
Can you just leave your answer like that?
Yep, that's 2 significant digits.
I have a question.
Yes.
So most answers will be in 2 significant
Nope, it
digits?
depends how many digits they give you.
They'll ask you like.
No, they'll give you, for example, I'll give you one. You have a problem like this. 0.692 miles. And I want to know how many meters. Now notice how many significant digit this one is. 3. They want the answer 3 significant digits now. Our software is not consistent. 90% of the time they wanted that number of significant digits. Every once in a while they ignore that. And I couldn't tell you when they want it. So a safe bet, always give them the number of significant digit you have there. They'll let you know if you're close to it or not. So now I got to find 1 miles to meters. Let's see, again, where's that cheat sheet? Miles versus meters. 1 mile, 1609 meters. A third of the way on the top. 1 mile is 1,609 meters. I don't know if you can see it. Everyone see that one? Let's use that. So 1 mile, 1,609 meters. Now these will cancel each other out. .609 times 0.692. Again, my answer is 1113.428. You'll see me struggling with my calculator because it cuts a little bit off the bottom. Mine has like a dead spot. Sometimes hard to read the numbers. Like, is that a 2? Is that a 7? So that's why there's a little strip thin missing there. So now, since that's 3 significant digits, to make it, that's the 3rd significant digit right here. Is that 5 or more? No. So that number is what? 1110 meter. Every once in a while we try to make you do some math there. And we'll try test it here. Bless you.
Thank you.
Okay. This is the piece of paper. That's the beginning of it. Can everyone see it? I'm going to take 2 turns of that. Can you tell me what the distance is, the length of that piece, if we do 2 turns? That could be a wheel rolling like this. It's going to go turn once and do twice. Like, how far did it go, distance-wise? Well, I need to know what the dimension of this piece of paper. So let me put my ruler here. It looks like 3.5 inches. Let me get in centimeters, because everything really in physics is metric system. Just a hair less than 8 centimeters. Is it 8 or 9? 9. So let's say the diameter is 9 centimeters. So if you do 2 turns, how far did you travel? And we'll test it there. We'll take a sheet, cut it, and see if we're right. So we said this is 9 centimeters diameter. 2 revolution here. How many centimeters the distance? Or how many meters, actually? Let's stay with the units. We'll do it in centimeters, then we'll do it in meters. So we get to measure it. It could be a bicycle wheel that made 2 turns. How far did you go? Or made 50 turns. How far did you go? Well, what is each turn is equal to? How do we figure what 1 turn is equal to, 1 revolution? Like if this one goes around 1 turn, and we cut that piece of paper after that, which will be this far, and we cut it, what is the length of that piece of paper? How do we calculate that mathematically?
Get the circumference of
Yes, the circumference. 1 turnaround is called the circumference. Circumference is what? So 1 revolution, that's the circumference. Isn't that 2 pi times r? Or, what's 2 times r? What's twice the radius? Isn't that diameter? So that's pi times the diameter. That's the equation for the circumference. So in this case, pi is what? 3.14. And what's the diameter? 9 centimeters. $28.26. That's for one of them. So if you make 2 turns, how far did you go? 2 revolution is going to be twice that number. So 2 times 28.26, 56.52 centimeters. That's what 2 revolutions equal to. If you want to convert that to meters, does anyone know how many centimeters in a meter? If you're a metric system person, you'll know that quickly. A meter has 100 centimeters on the sheet too. Oh, I want centimeters on the bottom, right? Now I want meters on the top. Notice centimeters on the top here. So 1 meter is how many centimeters? 100. So that's going to be 56.52 over 100, which is 0.5652 meters. Let's see if we write. Let's go 2 turns on this one, and let me cut that piece of paper. I'll wait till you finish writing. We'll measure it to see if that's really 56 centimeters or close to 56 centimeters. Here's 1 turn. Let's go, that piece of paper. Can you see there's 1 turn? And now I'm going to cut it right there at that edge there. Right here. So the top part, I don't care, because the bottom I didn't lay it correct there. Let's measure the length of it. So the top part is the good one. Here we go. Let's start from here. This is 1 centimeter. Can you see the 1? I'm going to mark it here. This is the beginning. Come on. This is 30 up to here. That's 30 centimeters. And let's go from here, which is 30. And what do we have? 26. Can you see 26 and a half? So that's 56 and a half. What was the math said to me? 56 and a half centimeters. Each turn is the circumference. The bigger the radius, obviously, the more paper. Like if imagine if this was really big, 1 turn is going to be much bigger there. We'll get to that too when we get to object that moves in a circle pattern, like a chairlift if you're a skier. Bicycle if you're riding your bike. Driving your car. The size of the tires will determine how fast you're moving. The bigger the tires, the faster you're moving, because the distance you're covering is bigger. When the radius gets bigger, that distance is bigger. Try to make sure we cover all the conversion problems. The reason we're covering this, because it's going to be in every single problem we do down there, down the road there. It's going to say, this person running at 16 miles per hour, I don't know, Usain Bolt, when he runs the 100 meter, he can hit top speed to 12, 13 miles per hour. We need to figure that meters per second, My top speed probably 6 miles per hour. Who knows now, Maybe even less. You go to the dentist, the drill spinning RPM on that one, 4,200. Like, ooh. What does RPM stands for? If we said to you, 4,200 RPM, what does RPM stands for? Revolution per minute. 4,200 revolution per minute. So if you want to convert that, we know the drill itself, if you look at it, it's really small, the tip of the drill. When they're drilling your teeth, if you ever had your teeth drilled, that little tip is very small. It might be 1 millimeter.
How are you doing?
Jimbo, diameter. How are you?
Good. Well, I had to come to work. What time does it start?
We start at 8.
You do?
Yep.
8 o'clock?
Yep.
8 o'clock? You've been here since 8 o'clock?
Yes.
What the hell course is this?
Physics.
Oh, torture. Now I understand.
Yep.
8 o'clock. All you gotta know is F equals MA, that's half the course. What are you doing? Oh my God.
Yep.
Good luck.
Mr. McDonald was my teacher in the 70s,
He
mid-70s.
was my stats teacher at Springfield.
He's funny as hell.
I love him.
Yep, he's crazy. So now the drill is 1 millimeter in diameter. That means that this, if you want to convert that to how many meters per second, like if you tie a string to that, little tiny string, when you turn that drill on, what's going to happen to that string? Isn't it going to wrap around the thing? And you're going to see that, for example, if the string looks like this. I like the demonstration here. Hey, get out. Let's say this is the drill, and you take a string and you tie it to this one, and as you turn this, and you're going to see this piece moves, right? Can you see it moving? That little knot there, it's moving. Assuming that radius doesn't get bigger, because notice the radius is getting bigger each time. But if it doesn't, how fast is that piece moving, approaching this way? How fast is it going? We need to know the distance traveled during that 4,200 revolution, and we know what the time is. Well, what's the distance? One revolution is what? That's the circumference of a circle, 2 pi times r. Now, let's see, circumference. It's 2 pi r, or pi times d. Now 1 millimeter. Milli is 10 to what power? 10 to the negative 3. That's what a milli is. So that's 3.14 times the diameter, which is what? 1 times 10 to the negative 3 meters. That's one circumference around, which you end up with what? 3.14 times 10 to the negative 3. So every circle that the drill goes around, assuming it doesn't wrap on the same spot, the thickness becomes more, that changes. But every time it goes around, 3.14 times 10 to the minus 3 meter move. Not a lot. But when you have 4,200 of them, so that distance is going to be what? 4,200. Notice there is revolution per minute. Let's talk about revolution. Each revolution, multiplication here, how many meters? Each revolution is 3.14 times 10 to the negative 3. We just did that. Each turn, each one of these revolutions equivalent to 3.14 times 10 to the minus 3 meters. Now, rev will cancel each other out. My answer is going to be in meters per minute. I don't want it per minutes. I want it per what? Seconds. Notice minutes on the bottom here. To cancel minutes from the bottom, then you need minutes where? On the top, because it's on the bottom here. And seconds on the bottom. 1 minute has how many seconds? 60? Notice the minute cancels the minute. Because minute's really in the bottom. To cancel it, it has to be, in this case, on the top. If you put it on the bottom, they don't cancel each other out. So let's do the math. This times this divided by that. 4,200 times 3.14 power of negative 3 divided by 60. And I got 0.2198 meters per second, which is roughly 0.22 meters per second. So when you see RPM, that's revolution per minute, you have to change it to meters per second. You can't convert that till you know how thick that rod you're spinning around. If it's a big one, that distance, 1 circumference is going to be 2 pi or pi times d. If d is much bigger than this, that distance is a lot larger there. So for example, if you're looking at the tires of your car, you said, well, when my car is running, the RPM is 2,000. Well, if that's how fast the wheels are spinning, the tires on your car is not 1 millimeter. The tire on your car is probably diameter 16-inch tires usually. You know, that's your car is 16, 16, 32-inch, probably close to 1 yard if you have a big tires. That's almost a meter here. Almost. A little bit less than a meter times 3.14. You end up with that number. You move at a high speed. It's not that small number now. So the bigger the tire or the bigger that diameter there, the bigger the circumference, and if the RPM stays the same, you move in much faster than a smaller one. That's why you see people on these little bicycles with little tires, they're pedaling, pedaling, pedaling. They're not going anywhere. The tires are small. You know? They're for fun. You know? You put the bigger tires on them. What the small tires allow you to do, you don't have to work that hard to pedal to get it going. It's much easier, but you're not going that fast. We'll get to that too down the road. Torque. When you're riding your bike going uphill, you switch gears. Now you're pedaling, 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 you're barely going uphill. But it doesn't hurt your thighs when you're pedaling now. Your legs are not that tired when you're pedaling going up the hill, but you're barely moving. But you'll make it up the hill.